Hello students. Today we are going to see how to balance a redox equation by using oxidation number method. Now there are certain rules, certain steps we have to follow to balance the redox reaction by using oxidation number method. Some rules are changed when the medium is acidic, and when the medium is basic, some different rule we have to follow. Now we are going to discuss about these rules in this video and how we are going to balance the redox equation step by step that I am going to show you. If you will do practice in such a way, then you can get good command on this balancing of the redox equation, because it is also important for your NEET and JEE examination. So if you have a practice of balancing redox equation correctly, you can answer the question correctly. So now just pay attention and carefully listen so that you can be able to balance the redox equation by using oxidation number method. Now here I have taken the first equation, that is magnesium reacting with nitric acid gives magnesium nitrate, nitrogen dioxide and water. In some redox balancing of redox reaction question, the equation is already given to you and you have to simply balance the number of atoms and the charges. But in some cases, you will be given a description of the reaction and then you have to write the skeletal equation by using correct symbols and molecular formulae. Now first of all, here whatever I have taken this reaction, the skeletal equation is given to you and you have to balance this redox equation by using oxidation number method. Now the first step we will see that write the skeletal equation containing all reactants and product. Already skeletal equation is given to you. You have to simply copy this skeletal equation in the step first. In the step second, indicate the oxidation number of each element above its symbol and identify the elements which undergo change in oxidation number. Second step, what you have to do? You have to write the oxidation number of each and every atom in the reactant side and product side. And you have to identify which atom shows change in oxidation number, so that you will get the idea that which element undergoing oxidation and which element undergoing reduction. So see here in this step second, I have written this equation again and I have mentioned the oxidation number of each element above its symbol. So oxidation number calculation already you may have gone through. If not, then I will prepare one video for that, how to calculate the oxidation number. So by using those rules, you can be able to calculate the oxidation number. Now here you can see magnesium oxidation number, it is in uncombined state, so it is 0. Hydrogen plus 1, here nitrogen plus 5, oxygen minus 2. Here magnesium plus 2, nitrogen plus 5 and oxygen minus 2. Here nitrogen plus 1, oxygen minus 2. In case of water molecule, hydrogen plus 1, oxygen minus 2. Now we have to check which shows change in oxidation number. Magnesium shows change in oxidation number. So magnesium oxidation number on reactant side is 0 and on product side it is plus 2. So there is an increase in the oxidation number by 2 per Mg atom. Each atom shows increase of oxidation number by 2. Increase I have denoted with upward arrow. Now when we are talking about decrease in oxidation number, so here nitrogen in HNO3 and nitrogen in dinitrogen oxide, you will show that it is plus 5, here plus 1, so you will get that there is a decrease in oxidation number which I have shown with the downward arrow, and each nitrogen atom shows a decrease plus 5 to plus 1. Plus 5 to plus 1 means decrease by 4 electron or decrease by 4 per nitrogen atom. So when there is a decrease, we will say reduction is taking place. When there is an increase in oxidation number, we will say oxidation is taking place. So here magnesium undergoes oxidation and nitrogen undergoes reduction. So this way you have to find out the increase and decrease of oxidation number. So now students, in step third, what we have to do? In step third, we have to find out the total increase and decrease in the oxidation number per atom and identify the oxidizing and reducing agent. Means in this step, we have to find out total increase. I have shown increase with upward arrow and decrease with downward arrow. So how many total electron lost and how many total electron gain, that we have to do with this step. Even this total increase and decrease in oxidation number per atom we have to do, so that we can be able to find out the oxidizing and reducing agent. Now in this case, magnesium loses 2 electrons, so oxidation number increased by 2, and nitrogen gains 4 electrons, so oxidation number decreased by 4 per nitrogen atom. We have to count total increase and decrease per atom. Therefore, total increase in oxidation number of Mg is 2, right? And total decrease in oxidation number is equal to 2 multiplied by 4 is equal to 8. How it is 2 multiplied by 4 is equal to 8? So here the nitrogen is having total decrease by 4 and one nitrogen atom will be having total decrease by 4. So there will be change in oxidation number of each nitrogen atom, or decrease in oxidation number of each nitrogen atom by 4. And therefore for 2 nitrogen atom it is equal to 8, right? So left hand side only one nitrogen atom you can see, but right hand side there are 2 nitrogen atom. That is why we are counting 2 multiplied by 4 is equal to 8 total decrease in oxidation number. Now what we have to do in the next step? The next step, we have to balance the total increase and decrease in oxidation number by multiplying oxidizing and reducing agents by suitable integer. Now we have to balance or equalize total increase and decrease in the oxidation number by multiplying oxidizing and reducing agent by suitable integer. Now here magnesium shows increase in oxidation number by 2, while nitrogen shows total decrease in oxidation number by 8. In redox reaction, there will be whatever number of electron loss will be equal to number of electron gains. Or total increase in oxidation number is always equal to total decrease in the oxidation number. So in this way, we have to equalize the number of electron in both the processes. And for that purpose, here total increase by 2 means total lost is equal to 2 electrons. So we have to multiply this oxidation reaction by 4. And total decrease is equal to total decrease of oxidation number is equal to 8. Means total gain of electron is equal to 8. So here 8 electron already there. So we are going to multiply reduction reaction by 1. And this way, by multiplying oxidation reaction by 4, we are making the total loss of electron or total increase in oxidation number is equal to 8. So total increase in oxidation number also will be equal to 8. In this way, we are equalizing the number of electrons. Now students, after equalizing the oxidation and reduction reaction, or after equalizing the number of electron lost and gain in the process, our equation becomes 4 Mg plus HNO3 gives 4 MgNO3 bracket twice plus N2O plus H2O. We already have multiplied the increase in oxidation number by 4. So I have multiplied here oxidation reaction by 4. So multiplied Mg with 4 and magnesium nitrate also with 4. Now the next step is balance all atoms other than hydrogen and oxygen. Now to balance the other atoms means we have to balance magnesium and nitrogen. Hydrogen and oxygen we have to balance later on in the next step. So to balance other atoms than hydrogen and oxygen, we have to check that whether Mg is balanced or not. So here 4 Mg are there. So here also 4 Mg is there. Now we have to check nitrogen number. So first we will check on right hand side. So here this 2 multiply with this nitrogen. So 2 nitrogen, 2 multiply with this 4. So 8 nitrogen. Then this plus 2, that is equal to total 10 nitrogen. 10 nitrogen are on right hand side. So obviously the 10 nitrogen atoms should be on left hand side. So I have multiplied the formula of HNO3 with 10. And here I have made 10 HNO3. Now oxygen and hydrogen we will balance in the next step. So Now balance hydrogen and oxygen atoms. Balance oxygen atoms by adding H2O molecules to the side where oxygen atoms are less. Where the oxygen atoms are less, we have to add water molecule. Now here we have to check where the oxygen atoms are less. So first we will calculate on the left hand side. So 3 multiplied by 10 is equal to 30. 30 oxygen atoms on this left hand side. And now right hand side. Here the oxygen atom we will balance in this equation, we will check first. So here 10 multiplied by 3 is equal to 30. And now here 3 into 2, 6. 6 into 4, 24. Right? So 6 4s are 24. 24 plus this 1, 25, and plus this 1, 26. So this way total 26 atoms are there on the right hand side. So left hand side 30, right hand side 26, and therefore we will get the 4 oxygen atom less on the right hand side. Therefore addition of 4 H2O will be there on right hand side. So in this equation I have added 4 water molecule on the right hand side. Thus this 1 water molecule plus this 4 water molecule is equal to 5 water molecule. In this way I have made the change in the equation by adding these 2 water molecules, and now our equation becomes 4 Mg plus 10 HNO3 gives 4 Mg NO3 bracket twice plus N2O plus 5 H2O. Now we have to check whether all the atoms are balanced or not, and then we will check for the hydrogen. So 4 magnesium atom on the both side. So I will write here atom on both side, magnesium atom 4 on both the side. Then nitrogen atom, 10 nitrogen atom on left hand side. Here 3 to the 2 into 4, that is 8. 8 plus 1, 9. 9 plus 5. Right? Here we have got 10 into 3, 30. 30, and here so nitrogen that is equal to 10. So 2, 4 to the 8, that is equal to 8, and 8 plus 2, 10. So here 2 into 4, 8. 8 plus 2, 10, and 10 nitrogen on left hand side, 10 nitrogen on right hand side. So here it becomes 10. Now we have to check oxygen atom. 10 3s are 30, and here 2 into 3 into 2, 6. 6 into 4, 24. 24 plus 1, 25, and this plus 5, that is equal to 30. So oxygen atom also become 30 both sides, right? Now we will check for hydrogen. So here 10 hydrogen atom, and here 5 into 2, that is equal to 10 hydrogen atom. So hydrogen atom becomes 10 on both the sides. So this way we have got that all the atoms are balanced. Hydrogen 10 on both sides, magnesium 4 on both sides, nitrogen 10 on both sides, and oxygen 30 on both sides. So this way you are getting a complete balanced redox equation. This is in the acidic medium because we are using here nitric acid. So this reaction is taking place in acidic medium, and we have got all the atoms are balanced over here. This is not an ionic reaction. If the ionic reaction is there, then you have to balance the charge also. But this is not the ionic equation. So we are just balancing all the atoms on both the sides. And here you are getting that all the atoms on both the sides are balanced. So there is no special need of balancing hydrogen atoms. And this is the complete balance redox equation. So that we have done the complete balancing of this redox equation. And in this way our reaction or equation is balanced. We will see the next reaction, how to balance the second equation we have to see. Students, now see the second equation, how to balance the redox reaction. Here I have taken the example of the ionic equation. So the question is given in this way. Write the net ionic equation for the reaction of potassium dichromate with sodium sulfide in acid solution to give chromium 3 ion and sulfate ion. This is the ionic equation, and you have not got the skeletal equation ready-made in it. Here the description of the reaction is given and you have to write the skeletal equation. So now see the solution. In that solution, the step 1, That is, write the skeletal equation showing all the reactant and products. Write their oxidation number above the symbol. And the step 2 is find out the increase in and decrease in oxidation number and identify oxidizing and reducing agent. Now here I have written both the steps and I will show both the steps in the same equation. So the equation is written in this way. Now potassium dichromate will give dichromate anion. So dichromate anion is having the formula Cr2O7. So here I will make Cr2O7. So Cr2O7 2 minus. Then sodium sulfide. Sodium sulfide will produce SO3 2 minus ion. It will produce chromium 3 ion. The product is Cr3 plus ion. And sulfate anion that is SO4 2 minus ion. If suppose this way, if the description of the reaction is given, then you must be aware of the correct symbol and molecular formulas of the reactants and products present in that description. Okay, now we will see what is the increase in and decrease in the oxidation number. Now here every element's oxidation number I have mentioned above their symbol. So in this formula of dichromate anion, chromium shows plus 6 oxidation state, oxygen shows minus 2. Here sulfur shows in a sulfide anion, sulfur shows plus 4, oxygen minus 2, chromium plus 3 already charges there, that is same the oxidation number. And sulfate anion, sulfur shows plus 6 oxidation number and oxygen shows minus 2. This way the oxidation number of each element's atom I have written on their symbol. Now we will check where the decrease and increase in the oxidation number take place. So from 6 to 3, right, plus 6 to plus 3. In this way the oxidation number of chromium ion is decreased. So oxidation number decreased by 3. Decrease I have shown with the downward arrow. Decreased by 3 per chromium atom. So here this is the reduction reaction taking place. And here sulfur shows increase in the oxidation number from plus 4 to plus 6. So increase in the oxidation number by 2. So oxidation number increases shown by upward arrow, increase is shown by upward arrow by 2 per sulfur atom. So the oxidation process is taking place when sulfide ion get converted to sulfate anion. So this way I have shown both the steps in this equation. Now we will see the next step. Now students, see the next step. In this next step what we have to do is find out total increase and decrease in the oxidation number. Now already we know that there is total increase in the oxidation number of sulfur atom is equal to 2. But the total decrease in the oxidation number per chromium atom, that we have to find out. So every chromium atom will show there is a decrease in oxidation number by 3. So there are 2 chromium atoms in the formula Cr2O7 2 minus, that is dichromate anion. So 2 multiplied by 3 is equal to 6. So total decrease in oxidation number per Cr atom is 6 and total increase in oxidation number per sulfur atom is 2. Now we are going to adjust the number of chromium atoms. So Cr2O7 2 minus plus SO3 2 minus gives 2 Cr3 plus and SO4 2 minus. So here 2 Cr atom was there, that is why product side also we need 2 Cr ion. Now next step is balance increase and decrease in oxidation number by multiplying oxidizing and reducing agent by suitable integers. Now in the step 4 we have to equalize increase and decrease in the oxidation number. Means we have to equalize the electron loss and gain in the oxidation and reduction process. So for that purpose we have got the total increase in the oxidation number is equal to 2 and total decrease in the oxidation number is 6. Therefore we have to multiply the oxidation reaction by 3 because total decrease in oxidation number means total electron gain is equal to 6. Therefore total electron loss also should be 6. So that we are going to multiply oxidation reaction by 3. And so here we are getting the equation Cr2O7 2 minus plus 3 is multiplied with this sulfide anion. So 3SO3 2 minus, then 2 Cr3 plus as it is, and we are going to multiply sulfate anion by 3. So we will get 3SO4 2 minus. In this way we have balanced the oxidation and reduction equation. Now students, see, we have written the equation in this way: Cr2O7 2 minus plus 3SO3 2 minus gives 2Cr2 plus 3SO4 2 minus. Here we have balanced the increase and decrease in the oxidation number. Now we have to balance all other atoms than hydrogen and oxygen. Let us check with this equation whether all the atoms other than hydrogen and oxygen are there balanced or not. So other than hydrogen and oxygen there is chromium and sulfur. So 2 chromium atom here, 2 chromium ion here, 3 sulfur atom here, 3 sulfur atom there. So in this way we have balanced both the chromium and sulfur atom. So no need for special balancing in this equation. Already it is balanced when we have balanced the increase and decrease in the oxidation number. Now the next step is balance oxygen atoms by adding water molecules to the side deficient in oxygen atom. Now when we are going to balance the oxygen atom, we have to add water molecules to the side deficient in oxygen atom. Let us check number of oxygen atom. So here 7 and here 3 into 3, that is 3 3s are 9. 9 plus 7, total 16 oxygen atoms on this left hand side. Here we have got in this equation 3 into 4, that is 12 oxygen atom on the right hand side. So in order to balance oxygen atom, I have added here 4 water molecules. So 3 2s are 12, 4 3s are 12 and this plus 4, 12 plus 4 is equal to 16. So both the side now oxygen atom becomes 16. Now next step is that balance hydrogen atoms by adding requisite number of H plus ions, not atoms. Here we are going to make the change, that is H plus ions on the side where there is a deficiency of hydrogen atom. So H plus ions we have to write. H plus ions to the side deficient in hydrogen atom. As we have added 4 water molecules to the right hand side in order to balance oxygen atom. So here 4 into 2, that is 4 to 8 hydrogen atoms are present on the right hand side. But we will find on left hand side there is no presence of hydrogen atoms. So left hand side is lacking in the hydrogen atoms. So we have to add 4 into 2, that is 8 H plus ions on the left hand side. So left hand side H plus ion and right hand side 8 hydrogen atom. Now we are checking the number of hydrogen, oxygen, sulfur and chromium in this equation. Because we have balanced oxygen atom by adding water molecule. So 4 water molecule added to right hand side. 8 H plus ion added to left hand side. Now we will check whether all the atoms other than hydrogen and oxygen are balanced or not. So chromium here 2 and here also 2. So atom on both the side, chromium atoms are 2. Then 3 sulfur atom on both the side. So sulfur atoms are 3. Oxygen atom 7 plus this 9, 7 and 9 is equal to 16. 4 3s are 12, 12 plus 4 is equal to 16. So oxygen atoms are 16 on both the side. Hydrogen atom 8 H plus ion indicating 8 hydrogen atoms on left hand side and 4 2s are 8. 8 are on the right hand side. So hydrogen atom number also become same. Now we have to see the charge on both the side. Because when there is ionic equation, we have to check number of atoms on the both the sides as well as the charge on both the sides. We will see here 2 negative charges and here 3 into this 2 minus 2 is equal to minus 6. So minus 6 plus this minus 2, right? So here I am going to write minus 2, here minus 6, here 8 into 1, so plus 8, right? So on left hand side minus 6 and minus 2, that is minus 8 plus 8 is equal to 0. On left hand side the charge has become 0. Now for right hand side, here 2 into this 3. So plus 6 and this 3 into minus 2, minus 6. So I am writing here in the bracket plus 6 and minus 6. So is equal to 0. So charge on the right hand side also become 0. So right hand side charge is 0. Left hand side charge is also 0. So this ionic equation is now completely balanced redox equation. So this way students, you have to do the practice and get good command on balancing of the redox equation. Thank you for watching. If you like my video, please subscribe my channel and press the bell icon so you will get the notification when new video is made.